So can I start our today's session then on equations of first order but not first degree? Or any other queries with regard to trajectories of the previous session? Is it fine now? Are you hearing me correctly? Audio? Thank you. Now let us start out today's session. So in the previous session, we have discussed what are the concepts we are going to do under this part. Can you recollect that again? The variations which will come under this concept? Yeah. Equations solvable for P, X, Y and Clairaut's equation. So, can you say about equations solvable for P? What is the criteria to check on that? A given equation is solvable for P? Yeah. So, first of all, it must be of second and higher degree. Later, we are going to factorize that. The given equation will be represented as P minus something into P minus something equal to 0. So that we are going to evaluate each and every factor individually and the solutions will be written as a product. Accepted? Right. So let us take a sample problem on that. May I know that, do you have any doubts with regard to trajectories so far discussed? Concept of trajectories. Thank you. So for this concept and trajectories, I will give one combined test. The daily test, I will say. So that which gives a good practice on the two things. Right. So please take the problem that solve 4 into y square plus p square, 4y square p square plus 2xy into 3x plus 1 into p plus 3x cube equals to 0. So please take a note of this. 4y square p square plus 2xy into 3x plus 1 into p plus 3x cube equals to 0. So can you recollect the criteria for solvable for x and y? Yeah. So if you want to say that an equation is solvable for y should have only power 1 throughout the equation and x should have power 1 throughout the equation. However, some equations will not contain x and y in total, but in such cases we always go with the power of p, what it is containing actually. So in some cases we can say that it is a trial and error method. First we start with whether it is factorized with respect to p or not. If it is not possible, then only we go with the other methods in general. So if you simplify this, 4y square p square plus 6x square yp plus 2xyp plus 3x cube equals to 0. So we are going to take the terms common. Take 2yp as common here. So which gives that 2yp plus 3x square into 2yp plus x equal to 0. Please check. Right. So on the whole, I just have written the terms. You can say we have rearranged the terms so that taking the terms common is possible. Now we are going to take each factor individually. So 2yp plus 3x square equals to 0, 1. And 2yp plus x equal to 0. So we are going to make it as variable separable. Sometimes what happens, after considering the individual factors, some equations will come under the category of variable separable and some equations will occur as linear equations too. It depends upon the problem which is given there, right? So can you solve these factors individually? Say, are you able to solve them? Right? Please go ahead. So here you have p is equal to minus 3x square by 2y, and here you have p is equal to minus x by 2y, and p is nothing but dy by dx. So now we go for variable separable and we will do the integration there. I think everyone is able to solve these equations for the integration part. So if you allow me, I will write the solution then. Please check on the solution. Yeah. So the only difficulty lies in taking the terms common. That's all. Except that it is very easy. Clear? So can I take the other model in this concept? Thank you. Please take a note of that. Whenever you feel difficult, you can raise the question. Thank you. So in this context, let me take the other one. So solve the equation xyp square plus x square plus xy plus y square of p plus x square plus xy equal to 0. Please take a note of that. And first of all, I am going to write the terms on doing multiplication, which gives that xyp square plus x square p plus xyp plus y square p plus x square plus xy equal to 0. Now you please give your inputs there so that what are the terms to be written together so that to take the terms as common, the values as common. Take it as 1, 2, 3, 4, 5, 6. So which terms to be written together? In order to take common, 8, 2, 3. So if you take common as xp, you will get x plus y here. Fine. So the same x plus y should come in the remaining 2. Accepted? So you please go ahead with your inputs. then is it possible for the others to write so? I think it is not possible. Let me erase this. Because if you look at this problem for the first time, we have to think about what is the process to be applied here and how to take the terms as common. Right? So just hold on a second, I will write in the middle my logic. This is one thing I have taken here. So this is my ideology to take the terms as common. Accepted? Yeah. Yp plus x into xp plus x plus y. That is also right. What you have written. So taking the each factor individually, from this you have yp plus x equal to 0, and here we have or xp plus x plus y equal to 0, whatever the way you write. Right? So if we stick on to the previous thing, so from this dy by dx is equal to minus x by y, or nothing but y dy plus x dx equal to 0, implies derivative of xy equal to 0. No. On integration you have y square by 2 plus x square by 2 is equal to c by 2. You can take like this. Accepted? For the first one. Right. So can you solve the second one then? So if you write that, it will come as so multiply the total equation with dx, then x dy plus y dx plus x dx equal to 0. So this will be written as derivative of xy plus x dx equal to 0. Then it will become integrable. So on doing integration, the result is xy plus x square by 2 is equal to c. Accepted? Right. So writing this and this solution as a product together, we will get the final general solution. So please take a note of that. Okay. Please take the other problem. Please take a note of that. So x square p square minus 2xyp plus y square minus x square y square minus x power 4 equal to 0. So I will give you 1 or 2 minutes time so that you are going to take the terms as common. Please go ahead. Tell me, is it possible to write the terms as common? So I feel that you are doing simultaneously with me. So please write the terms after taking it as common, the respective values. So we can add and subtract the terms also. That is also possible. So since 5 terms are there, you can add and subtract the values too in order to get a term as common. So we have one good input there, that 1 minus x square into, the other thing is y square plus t square, right? Minus 2xyp equal to 0. That's a good one. And we have to solve it. How to? That is the question here. On the whole, we have to represent it as product of factors in P, isn't it? So is it possible here? So as our friend said earlier, we have got a new question here. A new question is framed. I think this kind of model is asked in previous year papers. Now, whenever after taking the terms as common, this kind of typical thing arrived, since factorization is not possible for this question, I mean, p minus something into p minus something is not straight away possible here. So for this, we use the technique of quadratic equations. So we are going to treat the given equation as ax square plus bx plus c equal to 0. So here the variable x is nothing but the variable p. The differential p will be taken as. So what is a here? X square. And what will be b? Minus 2xy. And what is c? All the remaining terms in the equation will be taken as c. Are you getting the logic here? Say. Yes or no? All of you. So, in order to determine the roots of quadratic equation, you have the formula that x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So here, the variable x is nothing but the differential p. So using the technique we have, p is equal to 2xy plus or minus square root of 4x square y square minus 4 into a means x square, c into y square minus x square y square minus x power 4 by 2x square. So you please check on that, what I have written. The last part is not visible, however, you are going to get the formula approach here. Say. So this kind of technique we usually apply whenever the given equation is visible in this model. Please check. X and p has equal degree. It must contain x square p square term, and then we should have the terms without having p, and p should come like this. I mean, you are able to visualize the content like this: ax square plus bx plus c. And the other thing is, in the constant, each power must be even. Each power must be even. In other words, if you consider the terms power, it must be even, so that it is possible to write the given equation in that form. Accepted? So if you simplify the square root part, you are going to get the things as, after cancelling all the values, I am saying is equal to y plus or minus x into square root of x square plus y square by x. Please check. I have cancelled the square root values. I have cancelled 2. The square root portion inside will be written as x square plus y square. All of you agree for that? If everyone accepts with that, then I proceed further. Any other queries for anybody? Right. So here we use the technique of homogeneous. Because P is nothing but dy by dx. Now check. Each term here has equal power. Power 1, power 1, power 1. Since square root is there, it is also nothing but power 1. Accepted? So it is nothing but the right side function is homogeneous. We are going to apply the technique of homogeneous equations solution. So here you are going to write that y is equal to vx or y by x equal to v, and dy by dx is equal to v plus x into dv by dx. So dy by dx is nothing but p, so that will be written like this. So here you have v plus x into dv by dx is equal to y by x is nothing but v plus square root of x square plus v square x square. Accepted all? So that we have v gets cancelled, x also gets cancelled, implies that dv by dx is equal to plus or minus square root of 1 plus v square. Please check. On substituting the values y by x equal to v or y is equal to vx, this is the technique of solving homogeneous differential equations. Since the given equation has p square, that means p has degree 2, it must have 2 roots. That means 2 solutions we should get, because it has degree 2. The given equation has degree 2. First order, second degree differential equation. So by taking plus here, we will get one solution. By taking minus here, you will get another solution. So making it variable separable, we have dv by root of 1 plus v square equal to plus or minus dx. So obviously this is nothing but sin h inverse sin h inverse v, sorry. And you are going to substitute the value of v there. V is nothing but y by x. So sin h inverse y by x equal to plus or minus x plus c is the required solution. You can further simplify that also. Otherwise, you can leave the solution there itself. Accepted? Any other queries? Yeah. Here you are saying that how it is a homogeneous equation, right? Just give me an idea. Actually, we say that whenever you take a function f of xy, we say that it is a homogeneous function of degree 1, 2, 3, 0, etc., provided you are going to replace x with kx and y with ky. So that what happens, if k gets cancelled completely, we say that it is a homogeneous differential equation of degree 0. However, by replacing this on simplification, if you get k power 2 into f of xy, we say that it is a homogeneous equation of degree 2, like that. So the power of k, we are taking it as. So if you replace x with kx and y with ky, is the k gets cancelled completely there? Yes or no? So if I say like this, ky plus or minus kx, just hold on a second. So we are saying that the k will remain there so that it is not homogeneous. Okay? Right. So I want to give another ideology for that, but however you can stick on to the approach what I mentioned. Yes, answer will come definitely using this type of technique. Answer will come by using this type of technique. Okay, right. So let me take one typical problem on this criteria, factorization under P, so that then I will take the other model for equations solvable for y and also solvable for x. So take the equation so p square plus 2py cot x equal to y square. I say that this model has given earlier in the previous year questions. I hope so. You can check on that if possible. The previous year papers are there with you. Otherwise, you can leave. So, did anyone has any cross check with you for this question? Please check if possible. So, any idea for anybody on this? Yeah, we can have the same thing, same approach. Quadratic, we can go for that. You can go for the quadratic approach. Right. So, I will go with the solution part. So, taking minus b plus or minus thing, can I say like this? So, I am going to get it as so then I can write it as p plus y cot x whole square is equal to am I correct there in writing that? Say right. So here p plus y cot x whole square is equals to y square into cosecant square x. So taking square root on both sides, you will have p plus y cot x is equal to plus or minus y cosecant x. So you can apply the technique of minus b plus or minus also there. You are going to get the same answer. Accept it. It is the other way around. By adding a term on both sides, you are going to rectify as a square of something. Now you have two factors. One thing is p plus y cot x plus y cosecant x equal to 0 is 1. P plus y cot x minus y cosecant x equal to 0 is the other. And you are going to simplify that. So if you take this part, dy by dx plus y into cot x minus cosecant x equal to 0. So here two things come in getting the solution. First part is here straight away you do it variable separable, integrate and simplify the answer. That is one module. Other one, simplify this thing. So cot x is nothing but cos by sine, cosecant x is nothing but 1 by sine. So you simplify this first. At the end you do integration, you will get the same answer. Either the way is correct. So first you do integration, then simplify. That is one way. Other, first you simplify, then integrate. So both the things yield the same answer. Accept it. So can you try for that? Just doing integration? Because nothing difficult is there. Acceptable. Right? I will write the simplified answer to you. The same simplified answer. Y is equal to c secant square x by 2 is one answer. Another one is y is equal to c cosecant square x by 2 is the other. However, simplification varies from person to person. That was the final simplification. Maybe you have a little difference in getting the constant c, except that it is okay. So you please check on that, the integration part. So whether you do the quadratic approach or you just add the element on both sides, you will have the same answer under the integration part also. But the only difficult part in this thing is getting the idea that we are going to use the quadratic approach in this problem to solve that, even though it is looking as solvable for p. Accepted? Any other queries, please? So I just want to have one input from your side that on doing this kind of equations, first order and higher degree equations, then how to identify that the given problem is solvable for under this type of criteria, solvable for p, x or y. That is the only thing. Except else, it is nothing but just doing differentiation and integration, taking the terms common and having the solution. Nothing difficult is there. Accepted? So please take a note of this. Then I go to the other module, equations solvable for y. I think this much number of practice is good for you, so that I go on to the other model. I am going to start with equations solvable for y. Shall I? Thank you. I think all of you have solved this kind of problems earlier at BTech level. So these sessions are just like a refreshment for you, so that we have done this kind of problem or not earlier to cross check. Isn't it? We have done this kind of problems at BTech level on these models. So may I know how many of you have hearing for the first time? Hearing this session for the first time? or recollecting these things for the first time? Okay. Are you feeling any difficult with this thing, getting the solutions or approach for the questions, or comfortable? Right. So let me take the other one. So it is nothing but equations solvable for y. I am taking the problems under this criteria, under this category, I say. So take the equation y plus px is equal to p square x power 4. Just take a note of that. Then I will give the module how to solve the problem and what is the underlined idea in getting the solution. Later we go with the approach. After having a note, please inform. Okay. So the first thing is, whenever the given equation cannot be factored under P, then we take care that it may come under the category of soluble for y or soluble for x. So here I say that this equation is soluble for y because y has power 1 here. It contains x has power 1 and x has power 4, so it is not soluble for x. It is soluble for y only. So the fundamental thing is, whenever equation is soluble for y, we have to represent that y is equal to something. Whatever the equation it is given, we should have to write that y is equal to something. There we go for differentiation, then we solve the equation by considering the factors. Please understand one thing, that here solution is nothing but a relation between x and y, the dependent and independent variables, and that relation involves the arbitrary constant c. In a shortcut manner, we are going to write an equation containing the symbols x, y and the constant c. That is nothing but solution. Accepted? So, first of all, what we do here, on doing differentiation and making the factors, we are going to find a value for p. P is equal to something. Let me say p is equal to cx, p is equal to c by y, like that. Whatever the thing it is. Since it is represented as y is equal to something, we are going to get the answer as p is equal to c into x, c by x, c root x, like that. So we are going to get the value of p in terms of x and the constant c. So this value will be substituted in the given equation, so that the differential p will be eliminated. You are going to get the required relation between x and y, which involves c. Okay? Is the approach clear? Are you getting any confusion? Right. So let me go with the solution part. Since it has power 1 for y, it is soluble for y. I am going to write it as y is equal to minus px plus p square x power 4. Now differentiate with respect to x on both sides. So dy by dx is equal to minus p minus x into dp by dx plus 4x cube p square plus 2x power 4 p into dp by dx. Please check. Accepted? Queries in the differentiation. Right. Now, dy by dx is nothing but p. So take all the terms to one side, either this way or this way, as per your convenience. I am going to bring these terms this side. So you have 2p plus x into dp by dx minus 4x cube p square minus 2x power 4p into dp by dx. Now I am going to take the terms as common. So what I have to take from these two, if I take 2p, so 1 minus 2x cube p, and here if I take x into dp by dx, is 1 minus 2x cube p into dp by dx is equal to 0. Please check. So the result is 1 minus 2x cube p into 2p plus x into dp by dx equals to 0. This is the factorization value. Accepted? Any queries for anybody in having this answer? Please respond. Right. Now here, by taking each factor, we will get a value for p. If you take the first one, we have 1 is equal to 2x cube p. This implies p is equal to 1 by 2x cube. So if you substitute this value in the given equation, is the p gets eliminated or not? Say. So if I substitute p is equal to 1 by 2x cube in the given equation, p gets eliminated. So I got the answer. But the problem is, it is a solution, but it is not containing any arbitrary constant c. So the solution given by this expression is called singular solution. So what is meant by singular solution? It is not having the arbitrary constant. So we don't consider this factor and we consider this factor because it contains the differential. If you do the integration, you will get the arbitrary constant c. So after doing this product of factors, we mentioned that we don't consider 1 minus 2x cube p equal to 0 because it gives singular solution. And we consider 2p plus x into dp by dx equal to 0. So we have to mention this line in the exam. Okay? Is the technique clear? Yes or no? Right. Let me go further. So from this we have 2p plus x into dp by dx equal to 0. From this we have into dp by dx is equal to minus 2p. So dp by p is equal to minus 2 dx by x. So doing integration, log p is equal to minus 2 log x plus integration constant log c, which gives that p is equal to c by x square. Accepted? So if you substitute the value of P here in the given equation, P gets eliminated completely, and which is our required general solution. So what is the final answer? Y plus C by x square into x is equal to C by x square whole square into x power 4. That is the final answer. Okay, so we have to substitute the value of P in the given equation, and we have to write the final solution. That is the conclusion of the problem. So if we review the overall approach, first thing, y must have power 1 in the given equation. We have to represent that y is equal to something, then differentiate with respect to x on both sides. Then you will have the factorization, product of two factors will come usually. Then we are going to leave one factor because it is giving us the singular solution. We have to consider the other because which gives the solution which contains the arbitrary constant. So solution is nothing but we are evaluating an expression for P that will be substituted in the given differential equation, which gives the final answer. Okay. If any procedure approach is there, doubt, you can ask. Otherwise, I will take the other way around, other concept in this module. Yeah. Both singular, right? So in the question itself, I have calculated both. You can accept that, right? Both singular solution, general solution, right? Now, please understand one thing, that in this question, it has become possible for us to find P is equal to something. Sometimes what happens, it is not possible to eliminate P. So what does it mean? We are going to represent y is equal to something. We do differentiation, and in the factorization, it is not possible for us to eliminate P. In such cases, how to evaluate the problem? Now I am going to discuss. Okay, shall I continue? So please take a note of this problem. Y is equal to xp square plus P. Please take a note of that. Since you know how to differentiate that, so you go for differentiation. I am going to write the answer. You please check on that. Please check whether you have achieved this step or not. I am doing differentiation with respect to x on both sides. Then you can give your inputs to me. All of you, please go ahead. If everyone is clear in getting this equation, then I go further. Please take your time, do on your own, and then confirm the answer. Now, we have to understand one thing, that after the completion of differentiation, we should be able to draw the factors. Is it possible here, drawing factors? No. Can you say that drawing factors is possible here? So in the other way around, drawing factors is nothing but, in one way, it should contain the term differential dp by dx. This won't contain the term differential dp by dx. This kind of thing should be possible. Drawing factors. Is it possible for this relation? No. So what happens? we are going to take the other way around. So let us take dx by dp on both sides. So 2xp plus 1 is equal to p minus p square into dx by dp. And then we are going to simplify that. How to simplify that? Dx by dp this is dx by dp minus 2 by 1 minus p square once p gets cancelled, this will be 1 minus p, right? Or you can say that accepted. All. So can we say that it is a linear differential equation where the dependent variable is x, independent variable is p? All of you, any queries? So we are going to solve it under the linear model. So we are going to take the integrating factor. So e power integral 2 by p minus 1 dp. So e power 2 log of p minus 1. So p minus 1 whole square is the thing. And then coming to general solution, x into integrating factor is equal to integral q into integrating factor dp plus c. So this equals that. So is equals to accepted. So from this, if you take p minus 1 whole square to the right hand side, you are going to get x is equal to something. Yes or no? So in other words, you have found an expression for x in terms of p completely. Accepted? Right. So the solution, whatever obtained by you, you take it as 1. Please understand one thing, that it contains the arbitrary constant c. Now, if you substitute this x value in the given equation, so you are going to represent y is equal to in terms of p completely. So in the end, we write that it is not possible to eliminate p. So 1 and 2 together give general solution. That is the answer. So please take a note of this model. So this model is somewhat important. You can check similar kind of problems are asked in UPSC too, I can say. So please check on the approach first, then we will have a discussion. Once we have noted the total solution. Accepted all. Right. Now, how to say that from the given equation, it is not possible to eliminate P? Very simple. You are identifying that it is soluble for Y. You have done the differentiation. After doing differentiation, if it is not possible to take the terms as common, the other alternative is nothing but it will come under the category of linear model. You are going to solve it using the techniques of linear differential equation, and you are going to get a solution of X in terms of P completely. So that X value will be substituted in the given equation, and Y will be converted in terms of P completely. So in the other way, you can say that you are writing X and Y as parametric form. If you talk of coordinate geometry, X is equal to something, Y is equal to something you are representing, and that is called as general solution of the given system. Okay? Right. So can I take the other model? Fine. So at this moment, let me discuss about Clairaut's equation. So you are asking about the procedure, what to do there, right? The problem. Last part, right? So after finding X value, we substitute X value in the given equation. Then we have Y is equal to something. At the conclusion, we mentioned that for these two values, we give the thing that for X, the equation as 1, for Y, the equation as 2. At the last, we mentioned that it is not possible to eliminate P. So 1 and 2 together will give the general solution that we write in the exam. Okay. Right. So please understand one thing, that Clairaut's equation is a form which comes under soluble for Y. So Clairaut's equation is just a special case of equations soluble for Y. Why we are calling it as a special case? So please take an equation of the form Y is equal to X into P plus P square plus 1, let me say. So since Y has power 1, it is soluble for Y, you go for differentiation, do the factorization. At the end, you simply get that P is equal to the constant C. So whatever the equation you have considered, if the given equation is in the form Y equals to X into P plus some function of P, here you can have anything, P square plus 1, 1 by P, 2P by P plus 1, etc., etc. Exclusively a function having P. Such type of equation, we call it as Clairaut's equation. If you solve that, you are going to get the value as P is equal to C, a constant. So without doing the entire process, we simply mentioned that the given equation is under this form. It is known as Clairaut's equation. So the general solution is nothing but we are going to substitute P is equal to C. So the final solution is y is equal to xc plus c square plus 1. That's all. So the differential P is replaced with the constant C, which is nothing but the general solution. So on the whole, we are just doing that whatever the given equation is there, by doing the rearrangement of the terms, we are going to reduce that the equation as y is equal to x into p plus some function of p. And immediately we write that it is nothing but Clairaut's equation. It satisfies the criteria of the form. So general solution is given by replacing p with the constant c. So straight away we replace that, which is our solution. Okay? Is the ideology clear? Or am I moving fast? Right. So can I take the problems on this concept? Yes. Here x has power 1, p has power 1. It must be a function of p. So I can say one thing that you can take the Clairaut's equation for x also. So let can take x is equal to y into p plus some function of p. There is also Clairaut's equation under x, which also come under the same category. However, we stick on to this form only. Whenever the given equation is of the form y equals to x dot p plus a function of p, it is known as Clairaut's equation. The general solution is given by replacing the differential p with the constant c, which gives the general solution. That's all. So let me take a problem on it. Please take a note of them. Right. Now, if you take the first one, taking exponential on both sides, you have x minus y is equal to e power p, nothing but y is equal to xp minus e power p. So it typically satisfies the Clairaut's form. So here we mentioned that the given equation is of the form y is equal to xp plus f of p. It is Clairaut's equation. So general solution is nothing but y is equal to xc minus e power c. That's all. Okay. Right. If you take the second problem, straight away you can write that y minus px is equal to p by p minus 1. So y is equal to xp plus p by p minus 1. So it is of the Clairaut's form. So straight away we replace p with c. So y is equal to xc plus c by c minus 1 is the general solution. Now you have a clear idea what is meant by Clairaut's equation and how to solve it. Accepted? Any other queries, please? Yeah. The same question, what I have written there. This type of question, fine. Now see how simple it is. Yeah, 3px plus 4p square, exactly. please understand it should be only x and p. 3 should not be there. So you have to differentiate that again. So dy by dx p is equal to, you have to apply the product rule and you are going to do again. Right. So for the third one, if you take that to this portion, square p square minus 2xyp plus y square is equal to m square plus p square. So this will be written as which gives that there is the general solution. Please check on that. Now you can realize how simple it is to get the Clairaut's equation and solve the problem by simply replacing p with c, the differential with a constant c. On the whole, we are just doing that. We are converting the given equation in the required form. That's all. Nothing else we are doing separately. Accepted all? So let me take the other one. On this Clairaut's model, the typical thing you can expect on Clairaut's model. Shall I continue further? Okay. To solve the differential equation, px minus y into py plus x equal to 2p. Now here I say that even though you can rearrange the terms, substitution and simplification, it is not possible to get the required form y is equal to xp plus f of p. So that what happens, you can go with the regular procedure that you represent the given equation as y is equal to something. It is one model to solve the problem. Or you can take the factorization part, or in any other model you can solve the problem if factors are existed for it. The second thing is by doing suitable substitution, that means in place of x, in place of y, by doing suitable substitution, you are going to convert the given equation as Clairaut's equation. Please understand one thing, that the suitable substitution is nothing but we are using some transformations. So the transformations usually vary from problem to problem. But most commonly we use the transformations that small x square is equal to capital X, small y square is equal to capital Y for most of the problems. So whenever small x square is there, we replace with capital X. Small y square is there, we replace with capital Y. So what happens, if you calculate the differential, so capital P is equal to d capital Y by d capital X, nothing but y by x into small p. So what does it mean? Whenever small p is there, in place of small p, we are going to write that x by y into capital P. By doing this kind of substitution here, the whole equation will come as capital Y is equal to capital X capital P plus function of capital P. So this is the Clairaut's equation. We replace P with C. So capital Y is equal to xc plus some function of C will come, and in place of x we write x square, in place of y we write y square. That is the general solution. So what is the ideology here? If the given equation straight away is not convertible into Clairaut's form, then we are going to use suitable transformations or functions we can call upon, so that by substituting these functions you are going to get the Clairaut's form in capital Y, capital X and capital P. So by replacing P with C, we have solution. In place of capital X and Y, we substitute the necessary values. And these transformations will vary from problem to problem, but most commonly we use that capital X means x square, capital Y means y square as general transformations for all the problems. Okay? Are you getting the idea? Yes or no? Any queries with anybody? Right. So in exam, we mentioned that we are using the transformations x square equal to x and y square equal to y. And we have to write that capital P is equal to y by x into small p. Later on we go with the procedure. Let me go with it. So how to do the problem? Here you have so please check with the solution what I have done. Then you can ask your queries. All of you clear? Any doubts? Now, I just want to take one small concept, that equations solvable for x. So if we have discussed on that, then this part will be completed totally. Equations of first order but not first degree. Then in the next session, I am going to discuss about higher order differential equations and how to solve them. So if once we have finished with that total approach, so half of the ODE part will be completed. Okay. So shall I continue further or can I take the next session? Thank you. So I'm going to take it on soluble for X. So I just want to give the description. Later, we will have a problem session. So equations soluble for X is the same approach what we do for equations soluble for Y. Yes, the same thing what I mentioned earlier is equal to yp plus f of p. There also we replace p with the constant c, but usually that form will not be given. We don't go with that form usually. Right. So for soluble for X, the fundamental thing is in the given equation, X must have power 1. And you are able to write it as X is equal to something. Earlier, whenever you have written Y is equal to something, you have differentiated with respect to X and dy by dx is taken as P. Since you are doing the opposite, here we have to differentiate with respect to Y. So what happens? Dx by dy will be taken as 1 by P. And the remaining procedure is as usual. What it is? After doing differentiation, we are going to take the factors as common. And one factor contains the differential, the other is not. So let me say, if it contains dp by dy, this factor contains only p, differential is not there. We consider this factor and we neglect this because it gives the singular solution. So solving that, you are going to get p is equal to something just like c by y, c root y, etc., etc. Substituting this value in the given equation, we will have the respective general solution. So the pattern is so simple, just like soluble for y. There we differentiate with respect to x. Here we differentiate with respect to y. Remaining pattern is as usual. Okay. And earlier we have discussed that it is not possible to eliminate p so that the two equations together will give the solution. That also applicable here. In majority of the cases, factorization is possible. Getting a value for p is possible. Whenever it is not possible, you will have the equations like x equal to something, y is equal to something. That is as usual. Fine. The methodology. Any doubts? Yeah, the Clairaut special case you can take. So can't we let us do this thing here? Why should we have any hesitation here? Whether it is coming as Clairaut's thing or not? We have given that. So let us do it with respect to y on both sides. Let's do it now. How to solve? Taking the terms as common. You have to do further modification here, or you can convert in the form of dy by dt, so that it will come under the category of linear model and you are going to solve it. That's what I'm saying. If you solve that with the usual procedure, you should get that P is equal to C, right? Some constant. Yes. That's why, apart from checking that whether it is Clairaut's or not, I am doing it with the usual procedure. So that if I get P is equal to something, obviously we can confirm that it is Clairaut's equation. Straight away replace P with C. That is my intention. Right. I say that it won't come under the category of Clairaut's. You are going to do in the same pattern and you are going to get the linear model. So you are going to get two equations as x is equal to something, y is equal to something. Fine. In this model, you are going to solve that. Yeah. Since we have 4 minutes left, so I want to wind up our discussion here. Tomorrow I am going to take higher order differential equations, and I just want to take 1 or 2 problems on this solvable for x. That is sufficient for you. And obviously, I am going to give the daily test for a practice on orthogonal trajectories as well as the things which we have discussed today. Thank you very much. If you have any queries with regard to approach, you can ask. And all of you, I just want to have a request that since the previous year questions are available to you, you please solve them and try to submit the solutions in the Telegram so that others will have a good idea about this ODE, since it is an easiest topic. Whenever we stuck up with some problems, we are going to solve them randomly after the completion of this part. Okay? So thanks to all, and that's all for today. You can come up with your other queries. Is it agreeable to all what I mentioned? I think the question bank is available to everyone, right from 1992 to 2016-17. So at least for the covered topics, you can do that simultaneously as a practice. Any other queries, please? Thank you.